All right, this is probably one of the most important lessons that we do in this first semester of geometry. So we're going to talk about angle relationships today. It's lesson 2-3. And we're going to have a lot of angle pair names. And it's just critical that you know how to identify those angle pairs. I just can't overemphasize how critical it is. You're going to struggle the rest of the year if you don't do well getting these angle pairs down and start recognizing them. So let's just dive in here. The goals are I can define and name perpendicular lines, and I will be able to identify vertical, supplementary, and complementary angle relationships. And there's some others as well, but those are the hot button ones right there, okay? So let's just look back as a warm-up to kind of just talk about all the angles in this picture right here. We can't say, I can just tell you right now that angle A doesn't work for us because they're all angle A. They all have a vertex of A, so you can't just use a single letter. So that's out. But let's see if we can name some of these angles. I'll just kind of start over here on the left and work my way around. I'm gonna put an angle here. Call that angle 1, and that would be angle RAE. Let's see if you can find another one there. This is angle 2, and EAC. And you got angle 3 over here. I'll call that CAH. So I'm just kind of trying to organize myself here. So now, those are the 3 small angles in the picture, but now what happens when I start putting some of those together? Like what's angle 1 and angle 2 together make angle RAC? Okay, so there's a 4th angle. And then angle 2 and angle 3 together make angle EAH. And so what you have to do in some of those cases is, you know, if you're going to add angle 2 and angle 3 together, you got to kind of scratch out what's in the middle. And then you can kind of see EAH. You know, if you could highlight that out, you know, use like whiteout or something and get rid of that ray, it would help you see that picture a little better. But, you know, overlapping angles like that are not overlapping, but side by side, they're called adjacent. They make a larger angle, right? So you got to be able to name that. Do you see any others in the drawing? I think that's it. So we had 5 different angles in that picture right there. We could say angle RAH is a straight angle. Some textbooks do that. I just call it a straight line. I don't call it an angle. So it would just stick with those 5 there. So what are adjacent angles? Well, we just talked about that over here. Like when angle 1 and angle 2 are adjacent, they're next to each other. But you got to be a little more specific than that. So I can show you things that aren't adjacent, but they look like they might be. So 2 angles with a common vertex. So they got to have the same vertex. That's important. So you can't have 2 angles like this. Let's see, how can I do this here? Like this. So if this is point X and this is point Y, we'll call this point A and point B out here. Well, now these 2 angles don't have the same vertex, right? So those aren't adjacent. Common vertex, it's got to have a common side, so they've got to have a side in common. Like AX is kind of a common side for this pair of rays, but or pair of angles up here, but you know, notice they don't have the same vertex. So the common side here is this ray AE. Okay, so there's my common side. They both have angle or ray AE as one of their sides, but then no common interior points. So that means none of the points inside this angle can be inside this angle. So a picture of what that would look like would be something like this. That angle and this angle, well, they're sharing some common interior points right here. So they're overlapping. They're not side by side. So they have to be adjoining without overlapping. Well, and these don't have a common side either. Okay, they do have a common vertex, but they don't have a common side. So they break a lot of the rules there. Okay, so that's what adjacent is. So angle EAR and angle EAC with that EA being the common ray in this case, right? So notice how EA appears in both of these. Well, actually, I think the ray mark would go the other direction, wouldn't it? So like this. So ray AE is kind of the common ray there. Okay? Vertical angles. Well, vertical angles are not adjacent, and they're formed by intersecting lines. So these two lines cross, and they form four angles here, right? 1, 2, 3, and 4. But they can't be adjacent. So 1 and 2 are adjacent, so that doesn't work as a vertical pair. It has to be like 1 and 3. Those are non-adjacent angles, and they're formed by intersecting lines. It's also true that 4 and 2 are vertical. Okay, so when two lines intersect, they form two pairs of vertical angles. So they're kind of like, you see the big X there in the drawing, right? The two lines form this gigantic X. I'm not talking about the X label in the middle. And notice there's an angle above and below, so that pair are vertical. And then there's an angle on the left and the right formed by this gigantic X, and they are vertical. So that's the pairs we're looking for. So if you had anyone with 3 letters, we have EXR, that's angle 1, and AXC, that's angle 3 right there. And then EXC is angle 2 in the drawing now, and then angle AXR is angle 4 in the drawing. Okay? Sometimes it's easier to letter them, or number them than letter them, but I want you to have the practice on both. Okay? So another great fact about vertical angles right here. I just skipped right over it. It's one of the most critical things. You're going to see vertical angles all year, and you better know vertical angles are congruent. They are the same measure. So if I know this side is 53 degrees, then by golly, this one over here is also 53 degrees. Okay? It's a little fact you have to know there. Okay. A linear pair. Well, the drawing looks the same, but this time we're looking for a pair of adjacent angles. So let's give these a 1, 2, 3, 4 again. And so a linear pair are going to be like angle 1 and angle 2, and they form this line right here with their non-common sides. Their non-common sides are opposite rays. So you've got ray XR and ray XC as your two non-common sides, and they form a straight line. They are opposite rays. They go in opposite directions. So it's EX that they have in common. So remember, it says they're adjacent. Remember, adjacent angles have to have a side in common. Well, EX is their common side. Excuse me, ray XE, not EX, but you get the idea there, right? So ray XE is the common one. XR and XC are the non-common because they don't share that side, and those two form a straight line. Okay. Well, the same thing's true when you make this sketch. You actually create multiple pairs of linear pair angles, multiple linear pairs. So 1 and 2 form a linear pair. Well, let me clear this drawing out a little bit and just show you now. 2 and 3 also form a linear pair. Here's the straight line. Right here, this is their non-common side, and here's their common side. And three and 4 form a linear pair. Here's their, whoops, that's not what I wanted. Here's their non-common side, and here's their common side. And then there's one more that we haven't mentioned yet. And that's going to be angle 1 and angle 4. So 1 and 4 form a linear pair. Here's the straight line that their non-common sides form, and there's their common side. Okay? So you always get 4 pair, and they're always just side by side. Okay? So just to show you that one more time here. 1 and 2, 2 and 3, 3 and 4, 4 and 1. Those are all linear pairs. Okay? And here's the great thing about linear pairs. Supplementary are also linear pairs. So if you know how to name linear pairs, you already know how to do supplementary. And we'll get to that one here in a second. Complementary first. So complementary is any two angles whose measures add up to 90, and they don't have to be adjacent. And that's the big mistake a lot of students make is as long as they add up to 90, they are complementary. They could be two completely separate angles like this and like this. And if this were 40 and this were 50, then I could say, oh, those are complementary because they add up to 90. Okay, so they don't have to be next to each other. It's just in this sketch down here, they are. And notice in the corner here, I put this little right angle mark, right? So that's just to indicate this is a right angle, which measure 90 degrees. So now we know these two angles, and I'll call them 1 and 2 to make it a little more clear. 1 and 2 add up to 90. And so if one's 50, two's 40. If one's 60, 2 is 30. 70 and 20, 80 and 10, who knows, right? So as long as they add up to 90, that could describe angle EAC and angle EAR. Okay, they're complementary, they add up to 90. Supplementary, they just add up to 180 as well. And it's any two angles. Again, they do not have to be adjacent. They don't even have to be in the same drawing. Okay, that says adjacent. Can you read it? Sorry, a little sloppy sometimes. So these are the same pairs, like 1 and 2 add up to 180. So for example, if I told you this angle was 57 degrees, 57, what could I do to find this angle over here? Well, they add up to 180. So I just do 180 minus 57. 3, 7, 2, so it's 123 degrees. Okay. Well, 2 and 3 are also 180, and 3 and 4 are 180, and 4 and 1 are 180. Well, remember, verticals are congruent, so I'm just going to copy that 123 down here and the 57 over here, because I know verticals are congruent. Okay. So there we go. All right, perpendicular lines, they are just lines, segments, or rays, any one of the three that form a right angle. So down here I've got line RH and line AC, ray AC, and they are perpendicular because right there you see that they form a right angle, and the right angle mark shows us that. And this symbol, the upside down capital T, means perpendicular. So you're going to see a lot of symbols in this unit. One that means parallel is this symbol right here, just a pair of parallel lines. While we're talking about perpendicular, typically perpendicular and parallel kind of go together. So that's a pair of perpendicular lines or segments or rays. Okay, so segments can be perpendicular, a ray and a segment and a line and a ray, you know. So any combination of two of those can be perpendicular. Just put that symbol down, and then in the drawing you can draw your right angle mark. Okay. So now we just play what we call name a pair. So we need to name a pair of vertical angles in this drawing. So remember, with verticals, I'm looking for a big capital X in the drawing. So see this big capital X formed by those two straight lines? Well, the angles on either side are vertical. So I'll say, just to mark them here, I'll say it's angle 1 and 2 here. So it's this angle and this angle that are vertical. So let's name them with 3 letters. So just trace now. E, Z, B, and let's go S, Z, R. Okay. How about adjacent? Well, adjacent means they're side by side. So let's see if we can find a pair of angles that's side by side. So let's do it with the highlighter. So here's BZE. I'll choose that one. And then I just need to either move clockwise to a new angle or counterclockwise to an angle. Let's just go clockwise to this angle right here. So now I've got this angle 1 and this angle 2, and they are next to each other. They are neighbors, right? They're adjacent. Adjacent means beside, so they are beside one another. And so 1 and 2, let's see, with 3 letters, angle 1 could be named EZB. EZB, and then angle 2, EZA, looks like. This class is not an EZA. Just saying. Okay. All right, let's look at a different pair now. There were lots of adjacent pairs in this drawing. We could have, just do some other adjacent pairs. That pair's adjacent. That pair's adjacent. That pair would be adjacent. 4 and 5 would be adjacent. 5 and 1 are adjacent. So if you just pick out any 2 as you move clockwise or counterclockwise, you're going to get a pair of adjacent angles there. Okay, a linear pair. Well, linears are adjacent, but you've got to be careful. They really appear on one side of a straight line. So, like what I like to do is I like to identify a straight line first, and then just pick a ray that just breaks off that line. So you could pick ray ZE or ZA or ZS. Let's do ZS. And so there you see there's a pair of angles now that I've highlighted. It's this angle here and this angle here. And that's our linear pair. So we're going to call this angle 1, we'll call it RZS. And we'll call this other one SZB. Okay. And then really cool, supplementary just means linear. So we could copy the same ones down, but that wouldn't be any fun. Let's come up with a new pair. Let's keep our straight line. Let's keep this straight line here that's highlighted. Let's pick a different ray. Like let's pick this ray. And now we got to name this angle and this angle. So let's name this larger angle 1. So it's angle, I could go AZB or BZA, it doesn't matter which way. I'll go AZB. And we'll go with angle 2, we'll use AZ and then go to R. Okay, angle AZR. That doesn't look like much like an R, does it? AZR. There we go. Complementary. Well, there's only one pair in the drawing. So when you say complementary, remember you got to think 90 degrees. Okay, and you're looking for that right angle mark. Well, there's only one right angle mark in the drawing. Right? So we got to be careful with that. Here, let's see. So highlight those angles then. So right there, that's the 2 pair, right? That make that right angle. So the 2 smaller angles that make the right angle. So we've got to name the small ones now. So the upper one, angle 1, is AZ, and you got to go to R, and then you go back down RZ, and you got to go towards S. And those are complementary. Well, then perpendicular doesn't refer to angles, it just refers to a pair of segments, lines, rays. And so it's the 2 that form that right angle that we were just naming. So let's see if we can just highlight that. So the right angle in this case is this one. And so these are the things that form the right angle. It looks like it's line ES. Is perpendicular to capital T upside down, and we're going to name this carefully. Z is the end point, and then it goes towards A. So ZA would be ray ZA. Okay. All right, moving on here. So this one's a little different. Now what you do is I've given you an angle and you've got to find its partner. So if I give you RGI, that's this one, and we're naming a vertical pair, I'm looking for like the other half. Remember, vertical means you're looking for a big X. So RGI is like the upper half of a big X, and then SGH, this one down here, is the other half of that. So I'm naming this one and this one. So we'll go with SGH for that. Okay. Adjacent to RGI. Well, that's nice. We're going to keep that highlighted. But this time we're going adjacent to, so I'm just going next to it. So I'm going to go one clockwise over here, and that's going to be, stick with angle 1 and the angle 2, IGN. Okay. How about linear with RGI? Well, I like the fact that they keep using RGI. Well, wait a second, I'm the they. I wrote this, so let's try this again. Okay, so now I'm looking for linear with RGI. So what I need is I need a straight line. I either need RG, the line RG, to be highlighted the whole way, or line IG highlighted the whole way. So what I'm saying is, like, I want to extend RG back the other direction. And so RGS, that's the straight line. And now the two angles that are the linear pair are angle 1 over here, the original, and then this large angle. You got to kind of ignore this because it's not highlighted, right? So RGI is one angle, and then IGS would be the other one. Okay. Oh, then supplementary to RGI. Well, let's make it more difficult on ourselves. I always try and do more difficult stuff together, less difficult stuff alone. So I'm not going to extend RG this time. I'm going to extend IH like that. So IGH is my straight line now. So angle 1, and now the rest of this side. So this angle is angle 2. So I got to ignore this. So RGH. Okay. And then complementary to RGI. Let's just re-highlight that. So here's RGI. And I need the rest of the right angle, so that's this angle here. So our RGI was angle 1, so this is angle 2 here. And you can see that's IGN. So angle IGN. Okay. Hopefully that's enough practice there for you. You can try these. So then I would just shut the video, or pause the video, give these a try, and then turn it back on, and I'll have the answers for you here. Okay. All right. Hopefully you've done that. So vertical to RGA, that's opposite halves of the X. So I'm looking at an angle NGS, or you could have said angle SGN. Adjacent to NGI, well, NGI. So I'm going to go clockwise to NGS. Or maybe you went counterclockwise to angle IGR. Either one of those. Linear with NGS. Well, I'm going to extend GR. So I'm going to have NGS be the right half, and NGR, angle NGR then, is the other half of that. Now, what if you extended NG? So NGS, and then you could have said angle SGA. So supplementary to SGH, well, I've got to go entire angle, and I'm going to extend SR. So SGH and HGR. Or SGH and SGN. Could have been angle SG. and as well. And then complementary to NGI, there's only one. It's angle IGR. Okay. So again, this is a critical section of material. You've got to be good at identifying those angle pairs. And so the IXL C3 identifying angle pairs, guys, that may take you a while to do. I just need you to understand that it's going to take some time. It's probably going to take some time for us in class as well to work through that and really get you to the point where you see them.